Hello, welcome to another problem session. So today we have a problem from Indian JEE Physics Advanced 2021. This is a problem, it's an application of a very interesting application actually of buoyancy and ideal gas. And so you have a bottle and you're working with a glass test tube vertically up, and some water goes in there, and initially you have a inside there pressure is P0, this volume here is V0, some air is trapped there, and pressure outside here is P0. So everything is in equilibrium. However, you have to actually, when you put the cap on, you have to push it in order for it to be like that. So it's equilibrium with F cap. And you do something, this is given by that number. If you squeeze it, squeeze the bottle, it will change the shape, and the pressure developed will be delta P, P0 plus delta P, and some water gets squeezed in, and so there is additional water here. Now the volume here is V0 minus delta V, and the pressure there is P, same as this pressure, like P0 plus delta P, because of the equilibrium here. If the pressure was less, more water will kind of squeeze in. And at this point now, there's no cap. It just barely starts to float. That means around at this point, there is not in touch with the cap. Okay, so that's the situation. We're supposed to figure out, given the data, we're supposed to figure out what the value of delta V is and what delta P is, and supposed to give it in this cc unit and Pascal unit, and with a Y, just the factor that you have to give. Now you can see the units. You can keep P in Pascal. You can, if you remember, Pascal unit is in a SI unit of pressure. So it's a Newton over meter square. So it will be kilogram meter over second square, meter square. So this is kilogram meter second square, and it's not in the CGS unit. But you know, if you want to make it everything in the CGS unit, you can convert this. So this will be like 1,000 gram 100 centimeter second square. So this equals to 10 gram over centimeters second square. So it may work in this unit and then convert back there, or it turns out you don't need to do any conversions in this problem. Just we'll find that. But right now we just want to point out that there's a unit mismatch here, and you don't really have to do anything in this problem. Okay, so how would we do this? So let's look at what's going on here in terms of the buoyancy. So if you look at just this test tube, looks at this test tube, the buoyancy will be the volume of this cylinder, right? So if test tube is height h and in thickness is t, and the inside radius is r, then you can see that volume displaced will simply be pi r plus t square h. So this cylinder r plus t h, and okay, that's it, right? That's the displaced. And so the buoyancy will be, in both situations, it will be same buoyancy. It's going to be volume displaced times rho of water times g. So this is the buoyancy force. Okay. Now, if you look at this situation over here versus that situation, so you have a inside volume V in, if you look at the total, is pi r square h, and this inside volume consists of originally it consists of V0 for the gas plus there's some water. So if you look at that initially there, now here what you got is this changes to V0 minus delta V for the gas, and VW0 plus delta V for the water. Okay, so what we got now is we look at the forces. Let's look at the forces that's in there. So you have a force of buoyancy, and that's balancing the weight of everybody that's supporting the glass and the water, whether this much water this here. So and used to be F cap, which is equal to 0 in this situation. In this situation, F cap is 0, and when is this situation, F cap is not 0. So we just use this situation for forces because we don't need to know F cap in this problem. Okay, so we have displaced pi r plus t square h. That's the rho w. Let me erase this. Okay, so we are going to get this pi r times h rho w g. That's going to be the buoyancy part. This is the buoyancy part, must equal to mass of the glass part, and which is given as 5 grams. So let's call it mg plus the water is this volume, So VW0 rho W, is the mass of the water times G, plus delta V rho WG. Okay, so what is the VW0? So from here we can actually get the VW0 will be pi r square h minus V0. So this will be mg plus pi r square h rho wg minus V0 rho wg plus delta V rho wg. Now this is exactly same as that. So except that you have where you have r plus t. So we can combine them. So this just becomes pi r plus t square minus r square h rho wg equals mg, and then you have minus V0 rho wg plus delta V rho wg. Now you can see that this is the g's can all go away, g's can all go away, and then this stuff here is this stuff here is actually the volume of the glass, and which is equal to mass of the glass, density of the glass. And so you can see how I can combine this. So let me get these two over here, so I can combine this. So this is m times rho w by rho g equals to m minus V0 rho w plus delta V rho w. And then I can solve this for delta V. So you can just divide by rho w and go over this. So yeah, delta V will be V0 minus you have m, and then you bring this m over here, and so that's going to be minus m plus this m over rho w rho g. Now when you put these numbers, so let's put these numbers. V0 is 3.3 and m is 5 and rho w is 1, m is 5 and rho g is 2.5. So this is 3.3 minus 3 plus 2 is minus no so this is minus 5 plus 2 is minus 3, so it's equal to 3.3 minus 3 and this 0.3, and this should be Cc. And if you look at this answer is going to be x. So this x will be x will be x equal to 0.3. So we got one part answered. Okay, that's pretty cool actually. Let me erase this and try to get the second part. Okay, to get the second part, let's use for the second part. So we had gas. We had a gas here, and it's the same gas, is the same system, right? So you had some amount of gas, and its pressure became P0 minus delta P, and volume became V0 plus delta V. Or the other way around, this plus and this minus, and used to be P0 V0, and temperature was constant. So you know that P0 V0 equals to NKT, and P0 plus delta P V0 minus delta V times same NKT for ideal gas. This is the same on both sides because temperature is same, amount of gas is same as K is both some constant. From this you see have P0 V0 equals P0 plus delta P V0 minus delta V, and if I expand this it becomes P0 V0 minus P0 delta V plus delta P times V0 minus delta V. So this cancels that, and I can bring on the other side. So delta P will be delta V divided by V0 minus delta V times P0. So you can see these units here cancel out. So I don't need to change units. So everything will be in terms of P0. So P0 and delta V is 0.3, 3.3 minus 0.3. So if you have P0 times 0.3 over 3, which is 10 to the power minus 1 times P0. So if you look at P0, P0 is 10 to the power 5 Pascal times 10 to the power minus 1. So that's 10 times 10 to the power 3 Pascal. And so it's looking for Y value, and so this is the Y value, right? This is the Y value. So Y will be 10. Yeah, this was pretty cool problem. I think you can do pretty much faster if you don't have to explain. And when you're looking at the screen, it's kind of sometimes hard to notice if there are some mistakes. There are a lot of things you can learn from solving this problem. So I hope you can practice and maybe change some numbers. Maybe you can ask some more questions. What will happen if you had a film? I mean, something like this I've thought of. I had a test tube, and up to some point there was it was kind of a film. So increase the pressure, but you didn't push more volume in there. So what will happen? This film will kind of squeeze, but no water going in. You know, water level doesn't rise. So this is kind of an interesting twist on this problem. you can have other problems, like you can say there was a little instead of a test tube, you had a maybe you had a floating balloon, a tiny balloon, and so the balloon was floating over here, and you squeezed, and then the balloon got pushed down, and so how much will be the volume of the balloon afterwards? So there are kind of same problem and same kind of thing you can think, and you should be able to solve that problem. Just wanted to remind you that you can check out a lot more of these things at www.physicsbootcamp.org. Okay, take care. Bye.